start today by looking at the metadata that Data Virtuality exposes. And we're going to begin also looking at how we could put this together in a web format. So the focus of this presentation is going to be about building an imaginary website to display the metadata that we provide. And it's going to be, we're going to use a very rough mock-up. We're going to pretend that management provided a very rough mock-up. The focus is not on the front end. The focus is, and I also wanted to warn everyone, the mock-up is not pretty, and that's okay. What we're really concerned with is providing the back-end functionality. And a lot of the focus of this talk is going to be about being able to present the data. So if we have something in the mockup, I'm going to show where you can get the data, and also go over if there's any special considerations in joining the data or getting the data. I provided, if the data was not in the correct format, I provided all the views and stored procedures necessary, and all the code will be available on Data Virtuality's GitHub. So let's take a look at what we're going to build. So we're building a mockup. We want it to look similar to Data Virtuality Studio. We want to be able to list the hierarchies and the data sources. And we're going to have a tabbed area here, and each tab is going to have different content. So this is what we're going to be building. So let's begin by looking at schemas and objects and what this mockup would look like. Right? So we have our hierarchy here. We're going to look at our objects, and this would be views and stored procedures. And if we select on any of these, we want to be able to look at what columns it exposes and the data types, and also to look at the definition of the view or stored procedure. So let's focus on just this hierarchy, where we're going to get this data from and how we're going to display it. So the first thing is to get the virtual schemas. We're going to look at the table called schemas we're going to look at the table schemas in the schema sys. And one of the interesting things here to look at is the column called is physical. This is going to indicate if is physical is true, it's going to indicate that this is a data source and not a virtual schema. Right? So this is where we're going to get the name of all of our schemas and how we're going to list them. And once we have the list of schemas, we're going to look for all of the tables that are owned by this schema. So once we have this UID, which is the UID of the schema, we're going to use this in our subsequent queries to sys tables using this schema UID and using the UID from our previous query. And this is going to give us all of the tables that correspond to this schema, right? So this would get us this part right here. And also, the next thing we want is to look at the stored procedures in this hierarchy. So we're going to do the same thing. We're going to query sys procedures, and we're going to query it and filter on the schema ID, right? So this is an example of how to get it just for the metadata schema. So your developers would iterate across every single one of these. So for each schema, right, they would get the appropriate tables and procedures, and then they would move on to the next schema, say for instance, demos, and then they would get the appropriate tables and procedures for the schema demos. And again, here, this is the indicator of whether this is a data source. If it's a data source, it is true. And if it's a virtual schema, it's false. So let's look at the next part that we wanted. So this concludes how to get the data for the hierarchy. So the next part that we're going to focus on is actually viewing the individual objects. So here we're focusing on the objects, and this is the query you're going to use, right? We're going to query sys tables again, and we're going to query via filtering on the schema UID. And this is going to give us all the information about this particular, all the tables that belong to the schema, right? So we can see here that what we're querying is our Masterclass 2021 sample data. Let's quickly take a look at that in Data Virtuality Studio, right? So we can see here, this is all our information. And what we want is the same behavior, so that when we click on any of these objects, we are going to get the column information and we're going to get the definition. So we want the functionality to be very similar. So what we're going to do now is go over here and issue this, and this will give us all of the information about the objects that belong, or all the tables that belong to the schema. And one of the things that you're going to notice here is the type. So if it's a view, it's obviously going to be view. And the other type that you're going to look for is table. So if it's actually a table that is in the schema, it will show up here with that indicator. Also, again, we're going to look at the is physical. This is going to indicate whether this is a physical table or just a view. And also we have other metadata, right? Whether this table or view supports updates, its own the UID for this particular resource, this particular object, any descriptions that you have, whether the cardinality has been refreshed. So if Data Virtuality does not know what the cardinality is, it's going to show up as -1. Also, whether this is a system table and whether this table or this view or table has been materialized. Right? So we have a lot of information already provided by the system. And really what we want here is to be able to expose it to the end users. So one of the things here is, here's an example of the cardinality. So this corresponds to going into Data Virtuality and refreshing the scheme and refreshing the statistics. So right now, if we notice that it does not have any cardinality, Data Virtuality does not know what it is. So we're going to gather the statistics for the selected view. And this will sometimes take a little while. Go out to the database, run some queries on it, and we'll come back in just a second and see if, oh, excellent. That was pretty speedy. So now we know that this has 181, approximately 181 rows at the time that we gathered the statistics. And this is what we're actually seeing here, right, in our cardinality. So the interesting thing here is that you can indicate to the end users or programmatically query this sys tables to find out which tables or views do not have any cardinality. And why the cardinality is important is because it's used by the optimizer. So the optimizer will look and see if we are joining, say, for instance, a table with a million rows and one that has 10, then we know that what we should do is filter, send the IDs for the customer and filter the numbers, because we don't want to return all 1 million rows, right? We only want to return the ones that correspond to customer. So this way we can actually do, Data Virtuality can do filtering and perform better and smarter queries. So it looks like we have a question. The question is, are the statistics run continuously once we issue the gather statistics command, or is this a one-time thing? It's a one-time operation, and this can be set up as part of a job, and it can be also scheduled as a recurring task. And also gathering statistics, it will also show up in our recommended optimizations, I believe. Matthias, are you available?
Yes.
Do you know, Do you know if the cardinality updates are recommended by our optimization recommendation engine?
No, they're not in the optimizations tab. It's actually some thing that you would you right click on the data source. You can refresh metadata right there from statistics, gather statistics now. You can find statistic jobs, and you can also gather. If you say gather statistics now, it's a one-time job, and if you say gather statistics, it creates a job, which you can then schedule. So
All right,
both available from a right click on the data source itself.
fantastic. Okay, thank you very much, Matthias.
You're welcome.
So let's go back to our presentation. So far we've completed the hierarchy and we've looked at how to get the data for views and tables. So the next thing we want is the column information. We want to get the column information for each of these views and tables. So let's look at how we're going to do that. We're going to use the information from systables. And again, we're going to filter on the UID, which corresponds to this object. And then this is going to give us the table UID. So this is the same table, systables is what we've been querying so far. And now what we're going to do is look at a view provided inside of the metadata schema. And this one is called raw columns. And we're going to filter on the UID of the table. And this is going to give us a lot of information, including the column name inside the table, its ordinal position, any defaults, nullable, data types, precision if it's numeric. And this is how we're going to provide the information to the end user here. So let's quickly take a look at this because there's a couple interesting things about this view. In order to provide all of the necessary data, one of the things was we need to join the information schema columns, information schema columns, and sys columns because they provide different information. And a lot of the joins you're going to see are converting the table catalog, table schema, and table name and column name to lowercase to join. The data is stored in a variety of case. So some is uppercase, some is lowercase, some is mixed case. So it's always best practice when you're joining this data to use lowercase. And once we've joined the tables, also be aware a lot of the tables do provide a UID. So best practice and also much quicker is just join on the UID as we can see here. And also there's a couple of helper things that I've added, right? To take to aid in joining and make it faster is to take the schema name, table name, and column name and convert these into a hash, right? So if we query this, we're going to see that the last two columns are hash values. And because we don't always have the UID available, provided some easy helper columns here to perform joins. So you can see we have a wide variety of information, wide variety of data. And you can see here are the hashes for the various, either the schema and table or a schema, table, and column. Oh, one of the things too I wanted to go over is the name in the data source. So depending on your data source, this name might have different formats. It could have could be lowercase, uppercase, quoted in double quotes, single quotes, begin with a $sign. It really depends on the data source. So do not rely too heavily on using the name in the data source in order to perform joins, but this is really useful to expose in your tool if you want to allow the end user to be able to traverse and track all the way back to the data source and see what kind of data they're looking at. close that out, or else we're going to have 100 views. So this concludes how we're going to get the data for the columns. The next thing we're going to look at is the view definition. Where are we going to get the view definition? So the view definition is we're going to use another view from our created in the metadata schema, and we're going to pass it the UID. So let's go take a look at this. This is actual text here. So once you have the PDF, you're going to be able to select this. And unfortunately, I can't at the moment, but let's go look at the raw view definitions. And look at what we have here. And while that data is loading, let's look at what we have inside. So again, like a lot of the definitions, the sys tables and the sysadmin view definitions might not have a UID in common. So again, we're going to have to rely on using the schema and the name in order to join these. And because we're looking strictly at the view definitions, tables don't have view definitions. So this is why we're filtering, performing the filtering here in the where clause. And let's look at what our data looks like. So we can see here it's the schema plus the name is the one of the primary columns in this data set. And here we can see the complete definition of these queries. And this, using this column is how we're going to provide the information to the end user about the definition. And also we have a lot of interesting metadata, right? When it was last created, when it was last modified. Actually, Data Virtuality does a lot of type checking to make sure it's in sync with our data source. The data types, lots and lots of information you can expose to the end user. And while I'm here and we're looking at the description, I want to like tie this back to Matthias's earlier talk, talking about the naming conventions and how this can help you find data. So one of the things that was implemented in this metadata demo was how to search the metadata, which includes searching the descriptions. So if you've already implemented your system, it's not too late. You know, you don't want to go back and change a lot of code, renaming your views and schemas, but you can put in descriptions that follow the naming convention, right? That would help users find the data. So again, if you follow the naming conventions, put that into your descriptions. It's going to also be done programmatically. We covered programmatically running queries, dynamically generated data. We can use this also to build easier tools from queries. So do not ignore the description. It's really going to be key for building a good system that your users can search on and get information. So now we've covered how we get our views and our views and view definitions. And this concludes the implementation and where to get the data for our objects. So the next thing we're going to look at is our metadata search. How are we going to search metadata? So what we want to be able to do is, regardless of where you are in the hierarchy, we want to have a tab where the end user can search for the metadata. And what we want to be able to provide them is a place where they can type in keywords or partial keywords and have these appear with a list of definitions and a list of objects that they can then drill down into. So what we're going to call here is a stored procedure called search metadata. It's already been implemented, will be part of the code that we give you. And we're going to search for the term lineage, right? So it's going to search all of the table names, the schema names, the column names. It'll also search the descriptions. And if we find the data in any part, this is going to be what we return to the user in that screen. Also, for instance, we can support, it supports using wildcard automatically. So if you search for the term raw, it'll actually look for uppercase, lowercase, and any part where it appears, whether it's at the beginning or in the middle of the name or description. Now let's quickly take a look at the implementation. Essentially what it does, it converts our search term to lowercase and adds the percent signs for doing likes. And it goes through and we union all of the data. And so what you're going to get back here is a union with indicators indicating whether this is a schema, a name, the corresponding UID. We look at schemas, view definitions, tables, columns, procedure definitions, anything we want, we can search in here. And this is going to be what we provide back to the user. I'm going to pick up the speed a little bit. I think we've kind of gotten the hang of how we're going to present the data and the patterns that we're going to be following. So the next thing we're going to look at is permissions. So we want to be able to mimic a little bit of Data Virtuality Studio. And here we're going to look, we want to be able to list the users, all the rows, and the combination of users and roles. So if someone picks a user, someone picks a role, we want to be able to show what they can, who's actively part of that group. So let's start off with the users. This is the one we're going to focus on next and how to get this data. So we're going to be querying sysadmin users. This will tell us the name of the user, whether they're allowed to create temp tables, and also all of the roles, a list of roles that this user has or belongs to. The next one we want to focus on is the list of roles. So this one we're going to get from sysadmin roles. This is going to provide us with additional information, the name, whether this role is allowed to create temp tables or not. And the next one we're going to focus on is the combination of users and roles. This might not be something you want to show to the end users. It is defined inside of raw permissions. And let's quickly take a look at this one. It's fairly interesting. And what we do here is we show the purpose of this view, it really is to show how you would join between users, user roles, and permissions. It kind of does a bit of an explosion of data, and it gets a little hard to read. But one of the purposes was to show you how to join this data, right? And also how we can translate our permissions, like our create, read, update, into more user-friendly information. So here, once we get this back, we want to be able to look and see what kind of permissions this user has. Right? You can see here the roles the user has. And here we break out our identifiers, right? Our creator, the permission to create, read, update, delete, whether they have permission to alter and use and define views and stored procedures using languages. So this concludes where we're going to get our information for users and roles. Right, so far for permissions, this has already been covered. We just covered where the users, roles, and user roles. And the next thing we're going to look at are indexes. We want to be able to get a list of all of our indexes, and we want to be able to get a list of all of the foreign keys in our system. The really cool thing about data virtuality is that it not only looks at any keys or indexes created on tables and views inside data virtuality, but we also query the index primary keys and all of the indexes and foreign keys on our source system because it helps to optimize, right? So the great thing about this is that we can go through and in metadata raw indexes, we can get all of the information about what tables will have which primary keys, what column it's on, whether we have composite primary keys, and we'll look at that in just a second. The next thing we want to focus on is where we're going to get our foreign key data. We're going to get our foreign key data from the metadata schema, and we're going to look at the raw foreign keys. And there's a couple of interesting things that we'll look at. We'll look at what the index UID and how the foreign keys are related to the primary keys that we just looked at. We'll get to that next. So this concludes where we're going to get our index information and we're going to get our foreign key information. So now let's look at a couple interesting things. This particular index in my system is a composite index. Right. So this very same index, it has one single UID corresponding to this index, and it's going to have several entries. And the ordinal position tells us the order of the index. It's a unique index, and it is using the salesperson ID, territory ID, and start date. And also, we want to look at how these indexes are related. So if we look at our list of raw indexes, our primary keys, we can join this back onto itself, right? So right now here we have an index in Salesforce. It's a primary key, right? And we're going to use this index UID and we're going to join it to, we're going to use it to filter on the foreign key UID. And this is going to give us all of the foreign keys. So this is the UID here. So if you look here closely, the UID for the index ends in 322C, and the foreign key UID ends in 32CC. The actual index themselves, these are all foreign key indexes. These all have different indexes. So we can go back and you can look at and inspect each of these individually. So it isn't hierarchical per se, it's more of a network or a mesh or directed graph. And you can actually follow this and use this information to create a directed graph where you show all of the relationship between all of the tables. So the next thing, if there are any questions, I want to take a quick pause and ask if there are any questions on the information we've covered so far. And if people want me to go more in depth into the queries themselves, I'll do that at the end. I want to make sure I get everything covered. I have a lot of information to go over. One of the things that we're going to be looking at is resource dependencies. Before you can use any of these resource dependencies, we need to call the metadata stored procedure called init resource dependencies. This can also take a while depending on the number of data sources and objects in Data Virtuality. Let's quickly look at the definition of that. So essentially what we're going to do is inside of our analytical storage, we're going to create a table and we're going to create this dynamically. Should have used the stored procedure in utils, but I went this route. And what we're going to do here is we're going to create a root object, right? Because all of the data here for our resource dependencies is hierarchical. So then we're going to go through and we're going to use the view called raw resource dependencies. And we're going to go through and insert all of this data. And one of the things that we're going to do then is start to link up the data here. And this is what this loop does. So it helps to set the parent ID, what depth it's at. We have a question. Since DB collects index information, I'm assuming that queries written on DB are optimized when indexes unwind before they're translated and pushed down to the data source. Is that correct? And is that correct for all source systems? I don't know if it's correct, if that applies to all data source systems. It should, and I can I'll contact our dev team and get that question answered. But yes, Data Virtuality's query optimizer does look at the indexes on the system in order to build more efficient queries and also to know what kind of things to push down. So this is especially important when you have a very large table joining to a small table on different systems. So what if Data Virtuality knows the indexes, since Data Virtuality knows the indexes, and it also knows the cardinality of both. It will take the IDs in this from the smaller table and include that in the where clause as an in, right? So if it's querying the larger table, it will be large table ID in, and it will have a list of the IDs from the smaller table, and this will help to filter out our data. So we do our best to answer, we do our best to efficiently optimize all of our queries. Another question, can we search for indexes and metadata as a UI button in the future? That's a good question. I like that. That's a good idea. The purpose of this talk was to kind of build the infrastructure for people to build their own website and to be able to add. And we do include a metadata search capability inside of Data Virtuality. So I can look for all things here that have the keyword raw. And the way the way it's implemented internally is different than the way it's implemented inside Data Virtuality Studio, right? The way we implemented it in the metadata, right, was to leverage Data Virtuality's exposed tables and views and stored procedures. And internally, it might be doing different. So the results that you get using our metadata search might be different than the results that you get using the functionality provided by this talk, this webinar. But again, from Data Virtuality Studio, you can search metadata, and it's a fantastic tool. It's very handy. So let's get back to our presentation. So now that we have the metadata for resource dependencies set up, now we're going to be able to display the information here. And what we want here is to be able to click on one of these resource names and to show the dependencies, right? So we want to be able to click the schema Masterclass 2021 sample data, and we should get the list of tables and views and stored procedures that correspond to that schema. Right? And once we look at the views, we also want to be able to click on this and look at the dependencies that this particular table or view has. So, and the way we're going to do that is that we're going to execute a call. So once the user selected these, we're going to execute a call to metadata get dependencies with the complete name of this resource, right? So it'll include the schema, a dot, and the name of the view. And what you're going to get back from this stored procedure is this list of data, right? So this here corresponds to this view here, right? The complete name. And what you're actually looking at in the complete data set is a hierarchical view of all of the data, right? From the root, which is our schema, all the way down to the other schemas that this view depends upon. And we'll look at this in detail in the next slides. So here, what we're looking at is if we begin to inspect the definition or of the view nested salesperson employee person, right? The first thing is that it gives us the dependency of the schema, right, itself. It corresponds to this view here, right, number one. Number two, where it looks at, it gives us the definition of the view, excuse me, get a little tongue-tied, need a little bit of tea. There we go. So number two, what we're going to look at is the tables or views that make up this view here, right? So number two corresponds to nested salesperson employee, right? Number two here. And number three corresponds to Microsoft AdventureWorks 2019 schema person and the table person, right? So we can see this table here, right? And it also tells us what kind of data, what kind of resource type it is. So as we continue down, so if the next one, we look at number 4, right? We're looking at the definition of salesperson employee. So again, this is recursing back, right? We're looking at number 1, which is the dependent resource. It depends on the schema. It also depends on this view, number 2, which is nested salesperson. And if you look, you can start to see a pattern, right? I nested these views, right? Nested salesperson employee, and this depends on nested salesperson. And it joins on the employee table, number 3 here. So as you can guess, we're going to unwrap nested salesperson next. Right? So number 1, it depends on the schema. Number 2 here is dependent on the table Microsoft AdventureWorks sales salesperson. And number 3 is the name of the view that we're actually looking at, which corresponds to this right here. So if you begin to visualize this, you can begin to see how from these other views, right, that are inside nested salesperson, salesperson employee, and employee salesperson employee person, these are joining on tables from AdventureWorks, and these are actual tables. So as we can see that all of this is getting rolled up, right? And all of these depend on the tables inside of AdventureWorks. So the resource dependencies provided us a really nice hierarchy. And one thing I do want to go on, and I don't know if I'm going to have enough time to actually look at this later, but one thing I'd like to touch upon is the get dependencies. Double click too much. How this is written. So one of the things that you're going to notice is that in here, we have a recursive common table expression. So we have our anchor, which is the dependent resource name, and we're filtering it and joining it on the parameter we passed in, and then it is performing the recursion inside the common table expression. So unfortunately, I'm not going to have enough time to talk about common table expressions, and hopefully it'll be a topic from one of our future classes. So this concludes how we're going to get our data from for our resource dependencies. And next, we're going to look at our data lineage. And we want to get the data lineage that we have in Data Virtuality and Data Virtuality Studio, but we want this in a tabular format. This is great to visualize. I love this, but a lot of times what I really want to be able to show an end user is something in this format. So let's focus on this next and where we're going to get this. So again, you have to call stored procedure initialize the data lineage. One of the things you'll notice is that the data lineage data is stored in the analytical storage, and my analytical storage is Postgres, and that this initialization code relies on a couple of native stored procedures. They're included in the talk and GitHub repository, but essentially what it's going to do is it's going to drop the table if it already exists, recreate it, and then it's going to loop on the tables we want to look at, right? So we're going to look at the schemas, Masterclass sample data, and DWH, and we want to ignore all of the materialized tables. And then what we're going to do here is do a select star from that particular table or view, and we're going to call our sysadmin function get data lineage with relationships only, right? And we're going to then insert this data into the table data lineage, right? And at the end, we're going to call the native stored procedure update parent-child relationships. This is optional. And the reason you're going to see this here is the DWH DB245 just corresponds to the name of my schema in Postgres. So you'll have to update this if you change it. Again, it updates the table, and if you're implementing this on your own side, be sure to change the schema name. And what this is going to do is set the ID and the parent ID. And if you look here in their depth, what it covers is this is the original nested view, and it recurs in it. The depth here is this is the top view. This is one of the nested views, and this is the other nested view from within the employee table. And it's going to show us all of the columns that are exposed in each layer. And it'll also show us right now it's filtered by depth. And if we begin looking at this, what this does is on our source table, it says that the business ID, right, is acquired from the business ID and salesperson employee, and is eventually acquired from the other view, nested salesperson, right, the business ID. If you begin to look here, you can begin to see the parent-child relationships, right? So this is the parent query, or the top level query of top level view. And here we can see in the next level that this parent corresponds to this parent here following this hierarchy. And also, if you look here, we have this filtered in a different order. We're filtering it by the default order. We're filtering it by the depth. And we can see here that this view exposes the business entity ID, right? And this is actually obtained from nested salesperson, and it has the same name. It could be different. So what we want to make sure that we're not joining on the source column. So these could be different. What we're going to be joining on is the IDs. And again, here we can see the nesting of these and how this corresponds. So if you look here, we would join, this is the parent for this one right here, and this is the parent to this one. And this is the very deepest level of nesting for these views and where it's being acquired from. So some of the other thing is we can also look at the source table, where the source table is coming from, right? So even though it is exposed here, this business entity ID is actually coming from nested salesperson, and it has not been renamed. If it can be different, so be careful. Do not join relying on this column. And we can see here as we traverse further down, we can see where all of these data, all of these values are coming from. So how does this data lineage relate to other tables, right? So we go back, and if we look at our data, some examples, we're joining our metadata raw columns on our metadata, our table data lineage, excuse me. We're joining our data lineage onto our metadata raw columns, or using our hash key, right, this value. And this will give us, let me go back, let me run this in the view so you can kind of see what it looks like. So what we're going to be doing here, and what's being exposed by joining this, is not only do we have the lineage from the various the data lineage, but we also have the column information and column data types. This information. So great information that we want to expose to our end users. And so definitely take a look at these views. These provide examples of how to join the data. So this concludes how we look at data lineage. Quickly, there's a view inside our system if we want to look at failed objects. We're going to get this from sysadmin failed objects. Useful information for troubleshooting. And we're going to put this all together using the REST API provided by Data Virtuality. It's already implemented in Data Virtuality. It's on by default. From our web browser or from our web server, we can issue an HTTP post request and get a JSON response. So in this particular case, we want to look at, we're going to query our data lineage. This is an example using Postman. It uses basic authentication. It can be any username, any password. It doesn't have to be admin. And we are querying, we're putting into the body of the post request a SQL query. That's all that has to be done. And this is the JSON response that we're going to get back. And again, here's an example using curl. And again, very straightforward, very simple. We're just using a straightforward SQL query that we're passing to it, whatever we would have used in the previous slides. This is what we're going to use here. And also an example using JavaScript. And this concludes how we put it all together. So any questions, feedback? So if we don't have any questions or feedback, or if people are still typing, we're going to go on break next, and I'll be presenting the next talk, which is about using windowed functions to generate SQL reports, especially year-to-date temporal analysis, and also year-over-year, period-over-period growth. So if there are no questions, thank you very much. Enjoy a 11-minute break, and we'll start in 11 minutes, 15 past the hour. And thank you very much.